Today, we are stepping into the high-stakes, meticulously controlled world of analyzing unknown software. You know, we rely on software for absolutely everything these days, but it turns out when a piece of software is completely unknown to you, you can't just open it. We're going to explore the really fascinating methodology of air-gapped reverse engineering and how it serves as the ultimate protective shield when you're dismantling potentially hostile files.
So let me start off by asking you a pretty simple question. What actually happens when you double-click an untrusted file? Well, I learned that if you treat an unknown binary just like a normal Word document, you are taking a massive risk. Security experts actually treat untrusted executables like suspected explosive devices. Literally, clicking it on a connected machine is exactly like tripping a wire. You might accidentally trigger hidden network configurations or execute malicious instructions that you never even knew were in there.
And really, that right there illustrates the core of the solution. Think about a standard workstation. It's connected to the internet, right? That makes it highly vulnerable. If malware executes there, it basically has a bridge to everything else in your life or your company. But an air-gapped workstation, that is offline, tightly controlled, and totally secure. Think of it as a digital blast chamber. It's a dedicated environment completely walled off from your operational systems. That way, analyzing a sketchy file doesn't accidentally provide a backdoor path straight into your production network.
Section 1. The threat, the unknown binary.
To really appreciate why we need this blast chamber, we have to remember that any unknown executable must be treated as hostile until proven otherwise. We aren't dealing with nicely documented source code here. We're dealing with compiled machine code that could absolutely be intentionally hiding its true purpose. If you try to analyze it on a connected machine, the risks multiply instantly. It might attempt unauthorized network communication to phone home, or maybe retrieve heavier payloads, or, get this, even try to exploit weaknesses in your analysis workstation itself. The moment you give a binary room to breathe, it is going to try to compromise the system.
Section 2. The blast chamber, the air gap.
Now, an air gap isn't just about yanking an Ethernet cable out of the wall. It's a profound shift in methodology that requires absolute precision. You have to meticulously control exactly what goes in and what comes out. In this workflow, you acquire the file and immediately generate a cryptographic hash, basically a digital fingerprint, so you can uniquely identify it. Then, it's transferred into isolation, analyzed, and only safe, thoroughly reviewed findings are ever exported. This strict boundary is absolutely crucial. It prevents your air-gapped workstation from slowly turning into an infected, contaminated machine.
There is a golden rule in this field, and it goes like this. Transferring a binary does not mean executing it. This is the very foundation of static analysis. The whole goal is to understand the file without actually triggering its functionality. It's kind of like X-raying a bomb without starting the timer, right? We introduce the sample purely as a frozen object of investigation. We never treat it as trusted software that we intend to actually run.
Section 3. Dissecting with IDA Pro.
Okay, so how do analysts actually dismantle a frozen, incredibly complex binary? Well, I was amazed to learn about diffusal tools like IDEA Pro, which essentially acts as the central workspace for this. But, navigating thousands and thousands of lines of machine code is incredibly noisy. That's where FLIRT comes in. That stands for Fast Library Identification and Recognition Technology. See, compilers throw in tons of messy, standard boilerplate code that has absolutely nothing to do with the malware itself. FLIRT acts like this massive filter, instantly identifying all that harmless, standard wiring so the analyst can focus all their energy entirely on finding the actual malicious trigger hidden inside. But even with the noise reduced, analysts still face a massive wall of complex assembly language. Trying to mentally connect millions of tiny, low-level machine instructions is just exhausting. And that is exactly why the Hexrays decompiler is such a game-changer. It literally translates that overwhelming alien machine code into readable C-like pseudocode. It actually reconstructs the higher-level logic. Suddenly, this chaotic mess of jumps and registers becomes a clear, readable blueprint, which dramatically accelerates the whole diffusal process.
Armed with these amazing tools, analysts follow a very systematic progression. Step 1 is triage, mapping out the basic file format. Next up, they map control flow graphs. These are absolutely critical because they visually map out the conditional branches, showing exactly how the execution of the program moves. Third, they follow cross-references to trace exactly where suspicious configuration data is being processed. And finally, they document everything, literally transforming a chaotic binary into a highly structured, understandable model.
Section 4. Verifying the supply chain.
Now, we usually think of air gaps as being just for outright obvious malware, right? But this methodology is actually critical for something far more common, the software supply chain. There is a massive difference between trusting a supplier and actually verifying the software they supply. You know, a vendor might have a flawless reputation, but a routine update could accidentally contain a compromised third-party dependency. By bringing those vendor updates into an isolated blast chamber first, organizations can establish a secure baseline and independently ensure no unexpected, malicious logic slipped in.
And this brings us to a very important number, 0, as in 0-day vulnerabilities. Conventional security totally relies on known signatures, meaning, unfortunately, someone else had to get hit first for your antivirus to even know a file is bad. But static analysis inside an air gap, it doesn't wait around for a signature. Because analysts are manually examining the executable's behavior, they can spot highly suspicious logic well before a public vulnerability even exists. It gives you true, independent visibility into 0-day risks.
Section 5. Preserving enterprise knowledge. Look, defusing a bomb once is great, but if the bomb squad doesn't record their findings, the next time they see a similar device, they have to start all over again from scratch. The exact same goes for malware analysis. If an analyst spends weeks reverse engineering legacy software, and those brilliant findings just sit locally on their laptop hard drive, it creates a massive knowledge silo. The whole enterprise suffers from duplicated effort, and frankly, when that analyst eventually leaves the company, all that hard-earned context and knowledge just walks right out the door with them.
So, how do we fix this? Organizations absolutely have to shift from a siloed approach to a collaborative ecosystem like ESPIN. By utilizing technologies like IDA teams and a vault server right within the air-gapped infrastructure, the scope shifts from the individual analyst to the entire enterprise. Findings are centralized, which creates true institutional memory. The workstation remains securely isolated, sure, but the knowledge it generates becomes a shared, permanent asset.
So what exactly goes into this vault server? It's much more than just exporting a final PDF report. You're archiving the underlying assets. Custom automation scripts, deep vulnerability intelligence, notes on completely undocumented legacy architectures, and approved FLIRT signatures. That way, if a legacy system is attacked, say 5 years from now, future analysts don't have to start their investigation from zero. They can instantly leverage years of historical intelligence.
Ultimately, the core thesis of all of this is turning individual expertise into institutional memory. An air-gapped environment powered by tools like IDA Pro isn't just about stopping a single piece of malware today. It's really about taking the temporary, brilliant insights of your analysts and forging them into permanent enterprise-wide armor.